We're continuing with internal energy as a state function. And in the previous video, which I admit was a while ago, was entirely about just the work as a state function. But in this video, we are going to be talking about three quantities, that is temperature and the volume as well as heat. Now let's start with temperature. And before that, what is a state function? State function basically means that when there is a conversion of the conditions from condition A to condition B, we do not care how condition A to B was, how it happened. Okay, so it's irrelevant in terms of the way the change happened, but the point is A got converted to B. For example, let's say we have a temperature change. Let's say we are heating water. Okay, and the boiling point of water is going to be 100 degrees Celsius. That's the boiling point. We know that. And let's say we have the water at 20 degrees Celsius, approximately room temperature. And there has been a change from 20 to 100 degrees, obviously, when we heat it. Now, there could have been a change where the temperature got converted to, 25 degrees Celsius, and then it went to 30, and then it went to 40, and then moved on, and all of that happened, and then it came to 100 degrees Celsius. This could have happened. Also, there could have been a case where the temperature actually went back down. For example, it changed to 25 degrees Celsius, and for some reason, let's say the heat decreased for, we don't know what reason, but I'm just saying there could have been a reason why there was a decrease in an amount of heat, and the temperature could have gone to, let's say, 23 degrees Celsius. And then, it went to 30 and basically got converted, and we're back to 100 degrees. Both these cases, temperature has gotten converted to from 20 to 100. We do not care about all of this in between. And that is why temperature is a state function. Not only that, here, in the end, the boiling point of water is 100 degrees Celsius, and that was that was the temperature we got in the end. The next one is volume. Now, volume, if you think about the sources of water around us, okay, let's take, for example, a river or a lake, okay, a lake, and its source of water could be, rain. It could be, I am not very good at all of this, but it does not matter that what the source of water is. Okay, also in case of volume as well, if the volume decreased from 100 ml to 50 ml, there could have been an increase in between, there could have been a decrease. That is irrelevant to us. That the point is it got converted from 100 to 50 ml. The third is heat. Now, why are we talking about heat over here? As I told you, when we spoke about the internal energy being a state function, we talked about the fact that there could be a change in terms of heat of the system. Now, when you have a system over here, right, there are two conditions which are possible. The system is hotter than the surroundings, or the system is colder than the surroundings. So let me just write hot over here, and this system is cold. Now, what could happen? Okay, so when the system is hot, what it'll do is, a simple example of this. You have a glass of milk. Okay, the system is going to be our glass of hot milk. Let me be clear about that. Hot milk. And what's going to happen is, over time, the heat is going to be released out of the system. Right. And if it's piping hot, you can't drink it. That's why you leave it out to cool down. So the system is releasing heat to the surroundings. Does that make sense? So in this case, the system is hotter than the surroundings. Okay. And over time, what it's going to do is it's going to release that energy in the form of heat. So the energy is released in the form of heat. And in this case, a cold system. Best example, cold water on a hot summer day. So obviously our surroundings is much, much, much hotter than the system. So what happens? The surrounding will start heating up the system. So what will happen over time? The water will start getting warmer and closer to room temperature. Now, the best way to remember these two, or the difference between these two, is taking real life examples. Hot water, or a hot glass of, or a glass of hot milk left out over a period of time will lead to a release of heat, and that in turn will decrease the temperature of the system because the surrounding is going to be less warm, is not as hot as the system. When it's the other way around, when we have nice cold water on a summer day, over a period of time, the water is bound to get warm. And that in turn means that the surrounding basically gave some energy to the system. Now, this exchange of energy is going to happen till the temperature, or rather, this temperature of the surrounding and the system is going to be equal. So temperature of the surrounding equals to the temperature of the system. So this process will stop at a particular point. Okay, maybe once you can just try leaving something cold or something warm and seeing what happens over time. And over time, you will notice that there will come a point where the system and the surroundings have the same temperature. Now, here, basically, if you notice, there is a flow of energy from a place of high temperature to a place of low temperature to the low temperature. This is what leads to the exchange. Now, the exchange of energy that is happening over here is called as heat. So the exchange of energy that is leading to the differentiation or the change of the temperature is called as heat. Here heat is absorbed by the system. Here heat is given out by the system. Right. Now, let's take, for example, we have a container. Okay. And the temperature inside this container is TA. Okay. Now, it has it it's basically in a reservoir called as TB. Okay. So this container is inside a reservoir whose temperature is TB. Now, the difference, now basically what will happen is the heat is going to get absorbed from the system, from the reservoir by the system, because TB is first of all greater than TA. So the temperature is higher at TB. And so the system will absorb the temperature. And this difference in energy, difference in temperature can be given as TB minus TA. And from there, we get the conclusion that the internal energy, that is our delta U equals to Q. And when Q is positive, and when Q is negative. So when Q is positive, heat is transferred from the surroundings to the system. Basically, Q is positive in this case, and Q is going to be negative in this case. Remember, if you find the sign convention difficult, what I would suggest for you to do is maybe remember the examples. And the moment you remember the example, it automatically becomes easier for you to remember this. So with that, we're done with internal energy as a state function for temperature, heat, and volume. And then the next video, we'll be continuing with the first law of thermodynamics. And I'd like to say that I know it's been a while since I've uploaded a video, and I'd like to apologize for the same. And the reason for that is honestly, it's thermodynamics. Let's face it, it's bound to be a little hard, and I've personally been trying to avoid doing it, but I realized, you know what, it can't be as hard as I think it is, and here I am. So I hope you understood whatever I explained, and do reach out if you have any questions or if there are any suggestions that you'd like to make.